All right, welcome. Thank you for coming to Python Frederick. This is Python Frederick in July of 2019. We're going to talk about Git and GitHub tonight. This talk is really aimed at people that are new to development, new to safely storing your code and all sorts of stuff. So this is meant to be a primer and an introductory kind of material for you. So hopefully if you're a little bit more experienced, you can take some nugget away, but realize that that's the audience we're aiming for in this talk. I want to start this presentation by having you think and frame your own thinking in this process about a project that you're working on. Whether you're a web developer or you're doing some sort of game, or maybe you're a data analyst, you have some project somewhere, probably, that you need to manage, that you need to change and modify and evolve along the way. And so I want you to keep that in your head. I'm going to use a boring kind of folder icon to represent that, but you see the folder icon, think of your exciting project. That's how we're gonna go about this. So the core thing that we are dealing with today is getting from an initial incarnation of your project to a new version, and basically dealing with the subject of change. And how do you control and manage change in a way that will not get you in hot water, will not leave you with a broken system, will not cause you consternation with your coworkers. I mean, all of these sort of problems occur whenever we're dealing with change. Change is hard. We all know this. We all deal with this daily in our lives and the way we work with others. And so we're talking about change specifically at a code level and dealing with that problem. Because we need to answer this question of, if you're dealing with your project and you break things, whether that's, well, I would not say intentionally. I was about to say intentionally. That doesn't make any sense. If you break things by accident, how do you recover from that? And we have good answers, but we also have bad answers. And we're going to start with looking at a bad answer and to see if you relate to this. I know that this is maybe a little too close to home for me in the past, but one way to do this is managing things by hand. Maybe you've taken this approach where you have a directory, it's got all of your important files in it, and you take a copy of the directory and you give it a version name that you've crafted on your own, whether that's date or a letter or some random number, and you've got your copy. And that's the way that you've secured yourself and insulated yourself from any breakage in your system. But I think that path does not end well. And I've literally been in business situations where an email chain has gone something like this, where what was something kind of harmless became a version number, became a slightly modified version number. I mean, I think you can see where this is going. And I went to the point of absurdity just to really illustrate the idea behind this. So I would contest that this is not a good strategy for versioning code. Maybe it works for kind of a surface level project where you're dealing with like a Word document or something. I don't know. I'm not going to judge people that go this route. Like, if it works for you, fine. For code and doing software development, it's not a good long-term approach. So that's one problem that we're dealing with in this equation. Another problem with code is dealing with this issue of sharing with other individuals. Your code in a vacuum might be useful if you're the only one using it, but usually we want to share it with others. Maybe we're part of a team, maybe we need to present this to an organization. However you want to think about it, code by itself is not terribly useful. So we have this problem of sharing, and the problem looks like this. Once you've shared it and made these copies of stuff, then you have a problem of work can diverge. I have my version A, but I've given you version A, and I make a change and you make a change. Well, now whose version is right? We're left with B and C, and that's the real problem with sharing. So the claim I'm making today, and that we'll assess as we go on, is that Git is a tool that actually solves these problems, and you sort of have to take it at face value because I haven't told you what Git is yet. But let's introduce it. Git is considered a version control tool. This is a fancy software industry term for a tool that can deal with change. And it comes from a long history of such tools that I remember most of them, but I will not bore you with that history because it's not terribly interesting for this talk. Take it at face value that it is the most advanced tool and most industry accepted tool today to do version control. So that's sort of the basis for this whole discussion, this whole introduction to this talk, was to give you a framework of the problems. And now we're just going to get into it. We're going to get to work and look at Git and use it and give you the building blocks for going forward yourself and taking advantage of it. So we need a toolbox in order to do this. And the tool that I'm going to use today is Visual Studio Code. It is a Microsoft product that is free. It is compatible with Windows and Mac OS and Linux. So that's why I'm pitching it to you, because regardless of what machine, what laptop you came in here with today, you can probably use Visual Studio Code to go through the exercise that we're going to want to go through. We're also going to use Git. And thankfully, Git is actually integrated into Visual Studio Code. So if you get VS Code, I'm just going to start calling it VS Code because that's how we call it. Git's just already there. So that's cool. You don't need to install something else. And then the third thing is a GitHub account, which we'll use to interact with or to simulate interacting with other people today. So those are the tools in our toolbox. So at this point, if you're on a hotspot and you got your network connected, stop listening to me and make sure you have a GitHub account. You can go to github.com and there's a big gigantic form right on the page that says pick a username, give us your email, give us a password, and you're off to the races. So that's important as we go on to this. So try that out, create an account, and we'll use it up in very shortly. So I'm revisiting previous slides. The thing that I was asking was how do we get from version A to B, and now we're answering it with Git. And there's a bit of terminology that you need to latch onto that will help make a framework in your head of understanding this tool. And the core at this framework is this term repository. The repository is the representation of all of your changes in history. It's tracking everything about your code. It lives with your code, and it is the heart of Git. And so we're going to create a repository. And actually, let me see. Yeah, let's start doing that right now. So let's go to Visual Studio Code, and let's create a folder. We're going to open a folder, and I don't really have one yet. So we'll call this PyFred demo. Why not? And we'll use that as our workspace for Visual Studio Code. Okay, so this is an empty directory that we just created. There's nothing, there's no magic up my sleeve here. But we want to create this Git repository. And on the side, just to walk you briefly, very briefly through Visual Studio Code, there's your File Explorer, is the uppermost icon there. There's a search option. There is what's considered the source control tab. This is where Git lives, and we're going to interact a lot with it today. And there are debug and a marketplace, but really you can explore more of VS Code later. The ones that we're going to key in on is this source control one, and then maybe use the File Explorer to browse around a little bit. So you see, it's kind of hard to read maybe from where you're sitting, but that's a little GitHub or a Git icon. So we can initialize our repository. That's the step we have to make, and that puts a repository into our directory. And so we're going to tell it to do that, and suddenly we have a repository. It didn't look like any change happened, but that's okay. But if we actually create a file now to pretend to be a project, I'm going to call it project.py, we'll start to get signs that we have our source control tool connected properly. And the first sign that you can see is now we have a 1 lit up over here on the icon, and we have this little U that means updated or something like that. So there's indicators that Git is actually already doing something for our code. And I'm not going to go through a big Python project, but we're going to fake it today by doing a bunch of print statements. So we'll start with the canonical hello world to do that. And so we have, at this point, a working Git repository. You're already going, so good for you. So let's jump back over to the presentation. So the next thing you need to be aware of, the term you need to know is committing. That's the action that you're taking on your files in your repository, but it can also be this sort of, you can treat it as a noun. We sometimes call it a repository commit. So it's both. But you can think of a commit as a checkpoint in your code. And if you're at this place where you have a working version A, and you make your changes and you get to B, and things are still working, you can declare victory and you can check it in. You can make a commit and move on. So coming back to VS Code, this is a working Python file. I can prove that by going down here and running our project, and it prints hello world. Hooray, I know Python syntax. So we can take this and we can make our first commit to the project. So we come over to the source control area, and we want to make a commit. And it gets a little funny in this regard of there's actually like this intermediate step, and it's called staging. I don't know the best reason why they call it staging. I don't know if it has to do with theater. I don't know, but it's called staging. And
so, an analogy when I was like playing around with Git, they call staging like you put all your files, like their items, in a box, and so you can take stuff out, put stuff in, and it's still staged.
Yeah, exactly.
You actually put that box into the mail, and then it's gone. You can't get it back.
Perfect. Thank you. Yeah, that's exactly right. And the point is, like, we stage things because you may not want to commit certain files to your repository. Maybe you have output files that are just like text files that are coming out of your tool. You don't want to commit them. There's a whole host of reasons why you might not want to add something to your repository. So the first thing we do before we make our commit is to add it to stage our change. And we care about this particular project file, and also just for the sake of this discussion, we're going to commit this settings file that comes from VS Code. You can debate on your team whether that's the right thing to do or not, but we're going to do it for this presentation. So I have taken those two files and used the little plus icon that was there, and now these things are staged, they're ready to go. And as Mike mentioned, they can think of it like putting it in a box and getting ready to put it in the mail. So we can give a terrible first commit message of first commit and commit it. So this stuff is now locked away in your repository forever. As long as your repository exists, forever might have a little asterisk of you can modify Git history if you really get down in the internals, but don't worry about it. So that's controlling code. That's your first step along to using Git at a basic level. So what if we broke things? Let's go through that. And to do that, let's simulate something that's broken. Let's make a function, and I'm going to call it broken, and it's going to raise an exception, and the exception is going to be boom, and we're going to then call our function. Okay, so if we now try and run our project, oops. I mean, it was pretty obvious visually inspecting it, but put yourself in a hypothetical of you've made countless changes to your code and you didn't commit it, and you've suddenly hit this weird error that you don't know how to fix. How do you get around that? Well, we're going to do one more thing before we look at that. We're going to put another change in here because I want to illustrate two aspects of this. So we've got another print statement in here. So we run this now. Again, we'll get another line printed out, but we'll also get the exception in our code. So we have this ability to look at code from the point of view of what they call a diff. which just represents a difference. And it's a way to highlight what has been added and what has been deleted. And then we can do it very visually and get a really good idea of what's going on with the changes we've made. So if we come back, we're at the Source Explorer, and we click on the file, we're going to get our line of what has actually changed. And I have some black formatting, which is kind of muddying the picture because it changed single quotes to double quotes. Maybe that's annoying, but so essentially from the tool's point of view, everything has changed because our hello world line now has double quotes from the auto formatting tool, but I was hoping to have little pieces of this. So we can have parts that we care about in here, and we can have parts that we don't care about in here, and we can manually control each of those aspects. And that's not stated very well because I don't have the clear differentiation, but let's make a couple changes for a second to make this clear. Because what I want to have happen is, so I'm going to do a second commit. Sorry. Things don't always go according to plan, right? So I'm going to put a third line in. And I committed that broken stuff. That was bad, but we'll see why. We're going to do more broken with another exception. The whole reason I'm doing this is I want to give you a clear diff that makes sense of this all. And you can start to see it now. This is over on the side. This is called the gutter. And we've got our gutter has this indicator that this is a new line. It's green. Okay, so you can get it even when you're not doing the source control view. You can immediately look at that and say, okay, I've got changes here on this line and on this line. And at the bottom of our file, we're going to change this to call more broken now, just for the same error that we were getting before. Apparently blue is modified. So we've got a bunch of different kinds of changes we have. And now we want to review the different. This is what I really wanted to show earlier. Sorry it took so long to get here. What's clear about this is that there are two different sections of your diff now. You've changed multiple parts about this. There's actually a third one down lower showing the before and after of what's changed. So all of these things are captured by Git to give you a clear indicator of this is what's changed in your project. Okay, so back to our hypothetical scenario, we want to make sure that we keep the good and throw out the bad, right? So something that you can do with diffs is you can revert changes. You can revert pieces that you don't want. And this is a very useful feature. So we know that this is broken, and we've figured it out. We've done our debugging, and we want to kill this part before committing it. So you can should be able to revert this chunk of the code. The reversion should just delete that. And now we've got a problem because this is broken too. So we can clean up after ourselves, but we can leave the part that we care about. Okay? If my example had worked out perfectly, we only would have done this one time. So this code is actually still in a broken state. So we're just going to change this to pass to make it happy. So that's walking you through the pieces of looking at your diff and reverting out the parts that are not working. Let me pause there just to make sure everybody grasps onto that. So we've covered now we've covered repositories and commits and diffs. Is that core terms gelling with people, or are there questions about that? Cool. So I'm going to stick with boring commit messages. And I keep saying that because you want, ideally, your commit messages to be representative of what you actually did. If you put messages like this, there's ways to view the history in Git and give yourself a log of, here's the chronology of what happened on my project. I was adding this new feature. And if you do what I'm doing, which is bad advice, or of just putting in kind of junk in this message, which is a required field, then you're doing a disservice to your future self, because you're not going to have any idea of what's actually in that commit. So this is a excellent way to like give yourself a history. Yeah, what's up, Mark?
As a team, do you find like when you come up with a convention for the commit messages that you try to be consistent with, or not necessarily?
Yeah, it definitely. So the question I'll repeat: as a team, what's your commit message format? What's the value of that? What should you use? Each team varies, right? So I'll give you an example of my work. When we do our commit messages, we make sure to put our issue number in there. We use an issue ticket system, and it gives us a traceability from this commit was the fix for this issue number. So it gives you full history in that way, which is pretty useful.
You know, are the messages like automatically tagged with like date and time, or is that
They are, yeah.
So,
Yeah, so, whoops, I didn't actually stage that stuff. So this is one of the things I was actually looking at VS Code. VS Code does not expose this information super easily, but there is a plugin that's freely installable called Git History, and I think that's the name of it. And it will give you the ability to browse the history very easily. It's also possible to use Git on the command line, which I'm going to do here in the terminal. It's at the bottom. I'm going to just say git log is the name of the command. And here you can see it gives us unique identifier. It gives me as the author, the specific date, and then the message. And you can dig into more of those and expand on those to see like what files were part of those commits. There's a lot of rich history that's in there because it has to keep track of everything. So it's a matter of formatting it in a way that you would like. So that's commits and diffs and stuff. So how does this all work? You've taken it on faith so far that VS Code just does the right thing, but what's really doing the work? Where is this really going? And the answer is in this .git directory. So coming back to VS Code, if I do a long list on the files that are in here, there's this important .git directory. It's kind of maybe a little hard to see with this font for those of you sitting in the back, but it's there, and it's got a bunch of stuff in it. This being an introductory talk, I'm not going to get into the internals of the .git directory. There's some really cool computer science going on to make all of this work and work well, but I wanted to mention this point as both an interlude before we get to GitHub, but also to say, don't delete this directory. If you delete this directory, you suddenly no longer have a repository. It's just now a directory with code files sitting in it. So that's what the Git directory is for.
Is that like a master one, or do you have different Git repositories under different, like you got projects in different directories that you're using? Like,
yeah, you can have as many, each project that is its own repository, so it's going to have its own
so
.git directory.
Delete one Git repository for one project, but it's not like it's in the root directory, right?
Trying to.
How many of these are, like, say, on your, like, if I go to my command line, I see a Git folder in my home directory. But if I create something and use Git in some subdirectory, is it going to generate its own Git repository in that subdirectory?
Yeah, now you're starting to get into a subject called submodules, which you could probably do, and it is a more advanced topic. But at a general level, just trying to keep it broad, usually one repository has one .git directory as a rule of thumb.
You may have said this, but I think one of the mistakes I made was that I assumed that I had to have a different one for every file. And so I created each project was one file. And I think that's a mistake. So do you want to maybe...
Sure, yeah. The Git repository is meant to be for all files. We've been working on a singular file that we've called project.py, but if you create a new file, other py, it will also be added and dealt with in your repository, and so you can add and remove and change multiple files. All of those files can go together in a single commit. Like when we made our first commit, I committed both the project.py file and the settings.json file. That was an example of both of those things are there. So yeah, it's definitely meant to control sets of files and work with them gracefully. Because as a project scales and you have more files and your features get bigger, you're going to touch, like maybe you have some user interface stuff over here and some CSS files if you're doing web stuff, but you also have some business logic in your Django views or whatever framework you happen to be using. But they couple together. So you might want to commit that as a single unit to say, this is everything that we care about.
And they don't all have to be Python files too. You have like requirement documents and other things.
Yeah, absolutely. Yeah, Git, in fact, it has no notion of what it doesn't know about extensions. Mostly, if you don't count git ignore, which we can talk about later maybe. But it's dealing with files and the content of those files and the SHAs of those files, the hashes, and some other details that are part of that.
I came across a problem. I was thinking, like, because along with my code, I have a database and structure that has to be good with the code itself.
Mm-hmm.
But GitHub wouldn't let me save the backup because it's over 25 meg or something. I had a limit how big the file could be.
Yeah, there are some. So the comment for the recording was an individual had some really large files that wanted to check into the repository, but they were too big, basically, and GitHub rejected them. There is a large file extension that you can plug into your repository that is meant for like binary data, like a database dump of some kind, or video files or big images, anything like that. Because what Git is good at is text, lines of text that does a diff. What Git is really bad at is binary data. And binary is meaning like you can't open it and look at it and inspect it and see something reasonable. It's just going to look like junk because it's all encoded specifically for a computer. So you don't generally put those files in there unless you're using one of these extensions that are meant to hold these larger file types.
So what's considered a large file?
I think it depends on the server. I think GitHub sets it at 25 megabytes, but you could, if you're running your own Git, whatever, you could set it at 100 megabytes or a gigabyte if you wanted.
Yeah, I'm just saying, my added files are 250 gigabytes.
So that may not be like not the same best for Git, but GitHub will definitely kick it back, mostly because they want you to use that Git file store stuff and pay them extra money.
Another thing to think about that is you are keeping a local copy of every change. If they're binary changes, right, it's not like a delta, it's keeping every change, right? So if you're keeping big files and you're versioning them, you can take up a lot of hard drive space eventually too. You might want to think about that strategy.
Yeah, I mean, personally, mine, like, say, 250 gig, but that's like the raw data type of stuff. I mean, more doing versions of, say, like pipelines or something, which could be text
Right.
files.
Yeah. Cool. So that's a little bit of the internals, as much as I want to touch on. So now we're going to move to answering that other question about sharing, and this is where GitHub comes into the equation. So Git is a tool that's a repository. You can totally work with it offline. There's a bunch of ways to get repositories to different points, but GitHub as a tool is meant. I mean, their tagline, I don't know if it's still the same, but it was about social coding or social sharing or something along those lines. So they really, from the get-go, have been designed to make code sharing between people easier to do. So, whoops, I guess that was so let's jump over to the tutorial with that because this is moving on to the other stuff we can do. I'm going to bring up GitHub itself, maybe. And the first thing that we're going to do on GitHub is create a repository. There's me. So to create a repository on your account, once you've logged in, you can go to this repositories tab and go to this new button. And just like VS Code did with the init command that we started with, we clicked the little Git white button and it created the thing for us. That's what GitHub will do for us. So we're going to create a repository on GitHub as the central place. We're going to bring it down locally to our machine and then interact with it, push changes up, and then simulate being another user. That's kind of the core of what I want to walk you through, just so you have an idea of what's happening right now, and then we'll move on from there. So let's call this GitHub demo, and you can give it a description.
Sorry, just to clarify, are you saying this is an alternate way to have created a repository?
It is an alternate way to create a repository.
Okay,
So yeah, there's think about it this way. There are two ways that you can connect GitHub and local stuff. You can either take your local stuff and push it up to GitHub, or you can start at GitHub and push it local. I mean, either way, you gotta somehow connect the two. I personally find that it's easier to take this approach and do all the, like, create the repository at GitHub, and then copy my files into a new repository or start from scratch there. That's obviously a personal taste thing. If you want to go the other route and you have a local repository because maybe you've been working on it for a long time or with a different tool and you need to migrate over, by all means do so. And they have ways for dealing with that. In fact, it looks like there's an import a repository right at the top here. So they probably know that that's a common path to go down if you want to go that way. So we're going to start. This is a public repository. Let's put a README in it, sure. There's this git ignore file. So there are certain file types that you don't want to store. In Python, for example, there's files that are called PYC files. They're compiled bytecode. We don't need to get into how Python works, but they're extra files that you don't want because they vary between my machine and your machine. Like they're just different. And you don't need those in your repositories because they will actually cause problems. They will cause conflicts because mine will make one version, yours will make another version, and we're going to always be fighting that the versions will never agree, they'll never match up because of the inherent complexity of the different architectures of your laptops. So you explicitly don't want them in there because they're just going to give you grief. So you can pick a language as your git ignore, and this has been tweaked by people at GitHub to know that here are the commonly generated files that come from these language ecosystems. So we're at Python Frederick, so I'm picking Python, but there's, pick your language. There's Ada, C++, etc. Like it's a long list of stuff. A lot of stuff, thought has been put into that. COBOL probably, yeah. And we'll throw on a license for fun because if you're doing open source, licenses are a thing. So this is creating the repository for me, and now we need to get it into VS Code so that we can work on it. So let's go back to VS Code, and we'll open a new window. And I'm going to use its Command-Shift-P on a Mac, but it brings up this command palette. And the command palette is like keyboard access to get to some of the commands that you want to do quickly. And you can see I've been practicing this offline. So we want to clone, and then we want to get the URL to clone from. So when you're on the repository page at GitHub, and this has to scroll because there's it's low resolution, there's this big green button, and you can copy this thing right here. And this is the path to your clone, which is your repository on GitHub. We can put that into VS Code and hit enter. And we're going to give it a location. Sure, why not? Projects. And we'll say, well, let's put it in here. So what that did was it went out to GitHub. It grabbed the repository, pulled it all down, put it into VS Code, and these are the files that came with that creation of the repository. We can see them here as well on the web UI, but they're the same files, okay? And then we just get to work. We don't have to initialize a repository here because it's already been created. We have everything that we need to do to push code up and down and make changes and start sharing with people. So let's walk through some basic sharing mechanisms, and then we can explore a little bit more advanced sharing mechanism, and then we can call it a wrap, or wrap it, mixing metaphors. So we're going to use the same name that we used before, make a Python file, and we've got our new version. We want to save it, and let's use black, sure, why not? Okay. So we have our new files. They're showing on, there's the VS Code thing over here, there's the project. Let's go ahead and commit them. We want to stage them and say, again, don't use these kind of commit messages for actual interaction, would be my recommendation, but for our demonstration we can do that. So now we've committed this to the repository. But it's important to note that if you refresh over here, this doesn't magically happen. You still only have your code locally. We have to get our code up there, and the terms that we need to know to do that is pushing and pulling code. So we are local, we need to push our changes up, okay? So we want to push. And there's this little more actions here, and it gives you a long list of commands you can do with Git. And so the common ones are up top here. So we pushed our change. So now if we refresh in the web UI, hey, there it is. There's our project. So if you're a solo person working on a project, maybe all you care about is that my local stuff, if my hard drive explodes on me, because maybe I have a 2015 MacBook Pro and my battery is bulging and it's getting ready to blow up, that's a thing. You can safely store your code somewhere else. So it's backups for free, basically, posted on GitHub. And so that's one method of doing this. So the flow is just like you saw. Make your change, commit your change, push your change. And you do that rinse and repeat. So now we get into this aspect of sharing. How are we going to share? And I'm going to synthesize being a second user by creating a clone under a team account. So we'll see what I mean in a second. At the top here, and Bruce, you were asking me earlier about like the fork versus clone. They're basically synonyms. Fork is like the action, but on the other side of this, you get two clones. So they start at the same point. They can have divergent history after you've cloned them, but that's where it starts. So if I click the fork button, I have a bunch of groups that I'm a part of. I'm going to say put a fork in, or put a clone, same term, in the Python Frederick group. And so now I have a whole entirely separate project. Again, these are divergent histories. Like they're not going to magically sync up with each other. They are totally separate things that just happen to start from the same commit, the second commit. So what I want to do to simulate sharing is to do another clone in VS Code, and now we're gonna have to keep track of two different windows, and hopefully I can do that without stomping on each other. But we need to clone from here. So we want to open up a new window and bring up our clone. Again, it's the command palette. I don't remember where it was in the options, but there it is. So for Mac, again, it's Command-Shift-P, which brings up all these tools you can use. But we get our clone. We paste in our URL for where we want to do. And note this time, it doesn't say MB layman. It now says Python Frederick. That's one indicator that these are different things. These are different clones. It's going to ask me where I want to put it again. And this time, I do want to give it a different directory that's not my projects area. We'll call this pyfred clone. Just want to give them some separation, otherwise it's going to conflict of trying to use GitHub demo in two different places, and we don't want that. Okay, so now we've got a second clone, just living in a different directory on our hard drive, but having the same code. So from here, we can say Python Frederick change. And we can commit that. But we have to start asking ourselves, like, where's this commit going? So you have to start keeping track of these different repositories and where their location. That location starts to matter. Say first pyfred commit. So what I've done here is made a commit to this local repository for Python Frederick. It is not even close to the MB layman clone that's living on GitHub. Make sense? And if I do a push right now, which I just did, if we go back to the UI, and we'll start to notice differences. So I'm refreshing this page. Check this out. So it now says 3 commits, and this branch, talk about branches in a second, is 1 commit ahead of the MB layman. And over here, it's still in the second commit. So if you are a different user, you have not effectively shared yet. It has not gone to the right place. So how can we get it up there? Well, this is where we get to the simple way and then the more complex way. The simple way is if you already have access to the other repository, which the person would have to grant you, you can commit directly to their repository. So I pushed up to our clone first, but I actually wanted to push up to MB layman GitHub demo. And the way that we do that is by, we have to tell our local clone, hey, there's another location that I care about. It's over here. We need to give it a name. And we call these things remotes because it's at a remote location. So we're going to create a remote. We're going to give it a name. And then we're going to push the code to there because I have access to do that right now. So we need to come back to this repository. We need the same clone URL from before. And we're going to add it to our Python Frederick clone. I'm going to try and move these over so I remember which one's which, because I'm totally going to mess this up at some point, I promise. So bring up our command palette and say add a remote. The remote name can be anything. This is not a special string, but it's often called upstream. So if you think of your repositories as like flow of information, the MB layman GitHub demo is like the canonical repository. The Python Frederick GitHub demo is the clone that is the downstream. So you have your relationship between the two. So we call it upstream, and we pass it the URL to that. And now we have a remote defined for this repository that we can use. And let's say, you know, the 2 branches, the MB layman one we know is behind of this one right now. So we can say push to, and look, it gives us options. Origin is the name that's used by default to say your original point. But we have our additional upstream remote here. So we can click that, and it's working and chunking along and pushing commits up. And so if we go back to our GitHub page and refresh, now the 2 clones are at parity with each other. Did everybody follow that? I know that that's quite a bit of stuff that I just threw at you, and I want to pause and recognize that these things, like, I've been doing this for 10 years, so this is old hat for me, but this, you know, if you've seen it for the first time, it may not be super obvious.
It was a little complicated. I got the part about if you're sharing a repository, you can do directly. You didn't actually demo that, but that made sense. The second one, if you make a change locally and then you push to the far one, does it automatically push to the near one also, or you need to do it twice?
It does not push to the near one. So that's a good point. Thank you. Yeah. So in the scheme of things, we have 4 clones in play. There's 2 locally on my computer. One represents MB Layman GitHub demo. One represents Python Frederick GitHub demo. There's also 2 remote clones on GitHub itself. And at this point, this Python Frederick change line has been pushed, it is here in this one of the local ones. It's also been pushed to one of the remote ones and the upstream one. So we've gotten 3 of them. But if we flip over here, it's not there yet. Does that answer, so does that get to your question? Like, it doesn't magically get pushed back down?
No, I wasn't worried about this. I should have, but I didn't think about this one.
Okay.
If you push it, it sounded like you could choose to push a change that you made locally directly to the upstream.
Yes.
one.
Yep.
And if you do that, does it magically also get applied to the one in between?
No,
downstream?
it does not.
Okay.
Yeah, it's very kind of explicit, which is why the flow that I might show you next is probably maybe more commonly used. It's a little bit, it's a different scheme, but you can see the advantages of it. So to close off this pattern of if you want to share and kind of everybody's just agreeing to push to a certain repository and pull from it, the person on the other side, me in this case, would then pull. And this is gonna pull from my origin, which is the MB Layman GitHub demo repository. And in that process, it should pull that print line that we had before. Okay, does that close the loop? Seem reasonable? Okay. So that is like, if everybody has access and you're just kind of trusting, you do this, we're gonna work out our conflicts with each other, cool, go that way. Now we're going to talk about a scenario that's much more common in open source development and the actual interactions. Like maybe you are working on a new project and you don't have the access to actually push into that repository. How do you get your change, how do you get your feature into that system? That's what we'll walk through. So we're going to start from, let's start from our Python Frederick clone. Okay, and I want to simulate. I have a bigger change that is going to need some review, and it's going. I don't have the. I'm going to imagine that my ability to write to the repo, the other repo directly, is gone. This is where we just have to pretend because I'm not going to go in there and fiddle with my permissions on the repository, but we can work through that. The way that we'll do this is with branches. We saw on the GitHub UI it mentioned branches, and I just said glossed over it. But branches are a scheme to let you branch off of your main thing, do some work, and then flow it back in. Like the tree analogy is kind of suffers because in a real tree in real life, branches don't actually come back into the trunk. So maybe more like a river and tributaries might be a better way to think about it. But the idea is like you're going to split off, you're going to do some stuff, you're going to bring it back. That's the lifetime of a branch. They're meant to be, most of them are meant to be short-lived. You can have longer-lived branches, but it's better to have a short lifespan on those.
That means like railroad tracks.
Yeah, that's it.
You go off the main track and then come back down.
Totally. Railroad tracks are another great way to think about it. So, and there's the icon down here, and you can even kind of see, well, it's very blurry, but the icon for the branch symbol is a line that shows something coming off the side of it with, you know, a node, 3 different node points on it. So this is our branch here. So we can make a new branch from our master to apply our changes. We can commit to that branch, and we are essentially creating a separate history in our repository that you can have as many branches as you want, all at the same time, and be changing lots of things on them. Managing the complexity of that gets kind of unwieldy, and you definitely, and I would recommend like merging your work back into the master branch, which is what we're going to talk about. But branches are these kind of cheap to create things that allow you to create alternate histories. So we'll create a new branch, and we'll give it a branch name of feature That's sort of boring, but it works. So we're now on our feature 1 branch. And our feature is going to be yet another print statement to say, here is our feature. Okay. We want to stage that change and commit it. We added a new feature to the project. And great. Okay, so locally, there's cool things you can do about this. So you've made your change. It's in this branch. You can go back to your master branch, and your change is gone. It wasn't destructive. You're just like switching your view of your repository, which is pretty powerful. So we can look at both, and it pops back just by switching branches. So you can work on many things at once. Like if you have different problems to solve, different customers asking for different things, and you need to switch hats based on, like maybe you're an agency and have to respond to customer needs like that, you can do that. You can manage that stuff with using branches. And so now what I want to do is take the branch and push it up to GitHub. So it's telling me we have no upstream, and would you like to publish this branch? Yes, yes I would. And I'm going to publish it to my origin, because again, we're imagining that I don't have write access to upstream anymore. That's the split that's happened here. So coming back to this area, GitHub's pretty smart. They know when you're making changes. They know that people like to use the web UI. So they call out things when they notice these changes come in. So I pushed this commit up, and it was a new branch, and it says, you have recently pushed a branch. Do you want to compare it and create a pull request? That's the keyword to latch onto, is a pull request. So in our discussion, I said there's pushing and pulling. There's also like pulling code from other locations. So when you create a pull request in the terminology of Git, you're basically saying, hey, maintainer of project that I don't have access to write to, could you take my code and pull it into your repository? It's about your perspective. It's not my code, but your code is the canonical thing, and I'm asking you to pull my code into your code. That's the viewpoint. And the request, the page here, which really does not fit on this resolution, is telling you the direction. So it's saying, we're opening a pull request, and here is the branch that we want to go to. This is the repository, this is the master branch, and here's where we're coming from. And the arrow is kind of the hint of where's the data going to flow. And so you can swap these and switch all sorts of stuff here, but this is the thing that you want in this case. And you can give it a description, write a bunch of statements about why you think it'd be great to add this feature to the project, and you can create a pull request. And the pull request system is like the lifeblood of GitHub projects. This is how people interact with each other. This is where dialogue happens. This is the social sharing component of GitHub by and large. There are also issues, like if you are talking about the details of a bug, but when you're talking about the actual code changes that are going to go into a project, this is how it happens. So you've created a pull request, and now you can see all the bits of it. Like we can have conversation. There's a comment system. Whoops, didn't mean to click that button. There's a comment system. You can review, or the reviewer, whoever that would be, can look at what commits are part of this, what has actually changed that this person wants to add, and assess it. So now I'm going to flip hats. Now I'm going to be the maintainer, MB Layman, GitHub demo owner, and the one who actually has the permission to merge the code back in. And I'm going to review this pull request, which we just call PRs most of the time. And GitHub has a pretty nice review set of tools built in. I can click this little button on the side, and I can say something about the code here, like if I don't like it, I can comment on why, etc., etc. But I can just say, this is cool. And I can start a review. Now, there's only one line here, but you can imagine a bigger change that might touch dozens of files, like Tim was talking about, like repositories control a lot of things, and be all over the place. And there are parts of the code that I could like. There are parts of the code that I could say, hey, I think you need to change this. You're not following our code guidelines, or you didn't add tests to this part of the code, so we don't have any guarantees that this is going to work. And you can have that discussion and walk through that. So after I, as a reviewer, am done with the process, I can come through and I can go up and finish my review. Now here's where the simulation fails, because I am both the author of this PR and the reviewer of this PR. Had I actually been someone different, I would have been able to select either approve or request changes. But I can put in some emoji that says, hey, it looks good, and I can add the review for now.
So request changes is more polite than disapprove?
Yeah, there were, the first version of this actually had like a big red X icon. And you know, sometimes as a reviewer, it's like, my goal is not to make people feel bad. It's just like, if I'm accepting your code, I'm basically accepting responsibility for the life of my project thereafter. And so I might actually need you to make some kind of changes, not because I think you're a terrible developer, but just because I have to be the one to maintain this and feel good about it. So they did have a red X, and a lot of people were like, what the heck? It makes it seem like I'm just some kind of jerk that doesn't want this code. So they changed the icon to be like a little plus minus discussion bubble thing, to make it a little bit more neutral. But it's still red to indicate, hey, there are things that we'd like to change here. And then green, of course, is this happy check mark, but everybody likes green check marks. So you can provide your review, and if I'm the reviewer and I want to finish this off, I want to say, I want to merge it. And that's bringing the life of the branch to a closure, bringing it back in. There are different ways to merge. They have different meanings internally to Git, but they all roughly end in the same path, where the branch is now part of the code. So if I look at, if I go back to the main code area, we now see the interactions of this stuff is the merge request from the Python Frederick feature 1 branch has been merged. It's represented here in the history. We can see when it was created. We can see all the history of that stuff and follow and trace through everything that's happened. And it would look a lot more interesting if it was more than just me. So I apologize. Like it's a kind of a weird thing to wear both hats, but hopefully you can get the idea of what was happening along the way. So that's like the two primary modes that I would suggest people think about when they're working with Git repositories. Is either everybody has shared access and you kind of just agree to push files up, like you might have some sort of simpler needs than working on a big team, or you work more in this, I'm going to make a branch for my feature, I'm going to work on it, and I'm going to put it back into a pull request where it can be reviewed and compared by the team and get some buy-in before it actually gets merged. So let's go back to the presentation. Okay, so cool. What else can we do on GitHub? Now that you have the basic tools of here's your building blocks of how to do code, you can find lots of cool projects on here. This link, I'll bring it up, is really awesome. GitHub, by being as big as it is, I want to say it has like 36 million developers, is I think what they have on their main page. Just about everything is on this site, everything of substance. There are other tools that you can use, but the lion's share of cool open source projects have been put on GitHub. So you can go to the Explore page and you can go to Collections, and there are tools that are here for maybe you have you're learning to code and you want to look at some of the repositories that are there to help you do that. There's all sorts of categories of government apps and DevOps tool. Like there's just tons of stuff here. there's even interesting, like we were talking today about VS Code, and surely it's on this list. There's Atom. There it is. So the code for the very editor that we're using to work with GitHub and Git is also on GitHub. So if you don't like something about your editor and you're willing enough to go in there and learn how it works and change it, you can do that. This repository is managed by Microsoft, but they have an open roadmap. They have contributions from outside contributors, and you can become part of that space and part of that ecosystem.
You said open source, but if I've got the next $1 million idea that I haven't quite put out, and I don't want somebody grabbing it while I'm working it out, how do I?
So at that repository creation screen, there was also an option to make private repositories. So that if you do that, it's private. GitHub does need to monetize. So if you get your $1 million idea and you hire 5 other people, then suddenly you've crossed the threshold of how many people are allowed to share on a private repository before you need to start paying them. But if you're making millions at that point, throw them a few bucks. I mean, it's worth it. So that's where that comes in. So the second part of that is you can, as I said with like the VS Code example, you can contribute to open source. Like this is where open source largely happens, and it is a great way to build up a portfolio. Like if you actually find a project that you care about and find a bug and fix it, or maybe you start by making documentation updates to a project you really care about that the grammar is not quite correct or you think could be stated better. Open source people are starving for contributions, and if you can help in a meaningful way, you can get pretty far in your career with that sort of stuff. You can code with other people, like in your business idea example, whether that's a private repository or something public. It's just a good way to share code. And then I think this one is super cool and worth calling out is there's a pages system. So if you don't have web hosting or you don't know how to set up servers, or there's a lot of things that go on to making a website, GitHub will host it for you. So you make your repository, you drop in your HTML pages, and they will host it at yourusername.github.io. It also can hook in with DNS, so you can put in your custom domain as well. It is a super great way to start a personal website. Maybe you make a portfolio website, maybe you do anything like that. But this link, which again, I'll share all these slides out to the group, has all the information on how to get going. They have examples of tools you can use to do it. It is a really fantastic resource. So I think that brings me to the end. But I'm happy to stop and take questions, and then if there are no questions, we can move on to getting people set up. Yeah?
You didn't really delve into like using the command line to make the commits or pulls.
That's true.
Because I've used different text editors like Atom, Sublime Text, and even made changes in Vim. What about, you haven't really delved into, I mean, I know, but for other people.
Yeah, thank you. I only showed it, so the question was about why didn't I go into the command line? And part of it was aiming at beginners, I wanted to give people like VS Code has all the tools you need to do most of the interactions with Git that get you reasonably started. But yes, there's a very rich set of command line tools that come with this. It's actually how it started. So the history of Git it was a tool created by Linus Torvalds, the guy who maintains the Linux kernel. So he is like the hacker of hackers kind of type, and it would not sully himself with a visual GUI tool, I think. Although I can't say that for certain, I don't know him. But you can do everything that I showed you with command line if that's more your speed. So the push command that was in VS Code is git push, git pull, git log, I mean, there's a bunch of them. There's a handful, and I think the Git documentation you can go to, it's like Git SCM, but search for Git, it'll come up like the top result. The documentation will use the command line to give their examples, but a lot of that stuff translates to VS Code.
The collaboration and the branching and all that made a lot of sense, and I got that. But to keep it simpler, so if I'm just getting started, it's just me. Do I need branches? How often should I commit? I mean, because I'm not sure what I'm going to do right now is going to work tomorrow, so maybe it's not working in code, but I would hate to lose my progress anyway.
Yeah, it's all about what you're comfortable with. Yeah, well, there's no requirement that says thou shalt commit working code to a Git repository. There's plenty of good reason to commit something that's a work in progress, that's like broken, you don't want to lose it. A lot of people have a policy of, I'm just going to commit at the end of my work day and push up my code to the repository to keep it safe. That's totally cool. And that's a good way to go. For personal repositories, yeah, work straight on master. There's not, unless you're planning to share with someone or you have specific needs that you would know at that point, working on master is which is the default branch, sorry, is a totally reasonable way to go. Yeah, Jerry, what's up?
You can revert back to, can't you?
Yeah, you can. I didn't walk through any of that. That's a good point. All of this stuff is, yep, you can undo history and take out commits that were bad, and yeah, there's a lot of, by having the whole history at your fingertips, you can change history. I mean, it's a pretty cool tool when you get down to it. It's pretty awesome. Any other questions? Yeah.
Do branches come into or go out of existence once you sort of done the feature and it's part of the master branch?
Yeah, they will by default persist. They'll be in that magic.git directory. They'll be in there. You can prune them, you can delete them. Like if you've got the commits back on your main repository and you want to delete them, it's possible. It's not even that hard. Like in fact, after I hit the merge button with that PR, there's a big like delete button. So you can delete branches that are on your remote repository very easily as kind of a grooming, pruning action.
Another thing in terms of version control, which I don't really remember because I never really got into it like that. But if you're working on a particular thing, a feature, and you don't really want other people working on that particular feature, so that there won't be conflicts to resolve when you both try to get your stuff back into the branch, is there a way to block people from working on a particular thing? Do you say, I own this branch?
Yeah, you guys are hitting on all the little bits right below the surface. I love it. So the question was about what do you do when two people are working on the same chunk of code? Is that a fair way to summarize?
Sure.
Git will generate something called a merge conflict. So if you try and commit and something about the history has changed, and let's say you push up a branch and you want a pull request in there, if it doesn't have a clean, pristine version that it's working from where it knows what changed, it's going to throw up its hands and say, I don't know. I don't know if this code is good or that code is good. You tell me, because I'm not smart. I'm not going to figure this out for you magically. Sometimes it tries and does a decent job. But if it's a pure, like, this very same line has changed and somebody changed it this way and somebody changed it that way, it just says, you got to tell me which one's right. And it has modes of doing that with like little greater than, less than, and equal signs. It kind of blocks out, like, here's the chunk that's in conflict, and here's what we can't figure out, and pick between the two or mix and match between the two as you see fit. Clean up the little marker lines that say that it's a conflict, and then mark the thing as resolved. And then Git will clean up the rest.
Is there a way that when you're working on this with other people that you can kind of indicate to them that you are working in a certain area so that you can maybe avoid the potential for those kinds of conflicts?
I mean, yes, that's a communication issue. Like, it's a code structure issue of like maybe your project is has too many big files that cause too much interaction and needs to be broken up more. So there's like a structural aspect to it that you can help minimize that. There is just the good old instant message to the team, hey, I'm working on this, please. Like, I don't know, like I work on a code base that has 300,000 lines in it. So the chance of me and my teammate conflicting is pretty low. But not every project is 300,000 lines of code. So it depends on your project size. There's a lot of factors and variables that determine if you're going to have a conflict or not.
I understand the question more directly because some of the Microsoft products like Excel have ways where it'll tell you this file is being edited by somebody else who you're working off. Is there something like that?
Not that I'm aware of, unless somebody else knows, but there's no explicit locking scheme that I know of. And that was, I think, a conscientious choice because I've dealt with plenty of version control tools that do have locking, and then you always get that one person that goes on vacation and forgets to unlock the file, and you're like, or yeah, quits or whatever. And that leads to a whole different set of issues. So it's a different strategy of, like, we're just going to deal with conflict and we're going to figure it out versus we're going to try and serialize who's going to work on what.
I do wonder for some of those. I think Torvalds, he did this for Linux kernel. And if you could, and sometimes when I think about some of those decisions, like, why can't I lock files? If you think about that original case, it's like, if you want people locking files on this big open source project, and I think they were encouraging people to do very short, fast, small commits, in which case that's less of an issue. But, you know, like, I think it really did sort of flow out of maybe that original use case.
Yeah, and the kernel was born in, like, that's a million lines of code easy, or millions at this point. So, like, the lock scenario was not a feature that he probably needed because he's working over here, somebody else, there are thousands of people working on it all at the same time and can make it work. So I think that, you know, looking at the history is also informing its mode.
I just wondered if there was something out there.
Yeah, no, that's a great question though. Yeah.
I didn't,
Something else, and then we go to merge, and
Yeah, and it's, I mean, you said you're a student, right? So it's like school projects, your project size is probably a few thousand lines of code, and that conflict percentage is way high. And then,
we don't really do anything.
okay,
In school, no, actually, that's just personal projects and friends.
all right, cool,
We're trying to work on a team. I didn't.
yeah.
Well, it was like, you know, I did work there for 3 years and it happened maybe 2 times, 3 times. So, you know, like you were saying, with the percentage chance of happening is very low.
Right.
Unless you're working with like 3 or 4 new developers who are trying to create a $1 million startup.
I mean, conflicts happen. I'll give you a good example. At my company, I introduced this code formatter called Black, and I created some challenges because what Black does is it automatically restyles all the code. So anybody that had code that was existing at that moment, there's a good chance that the lines that the tool was automatically monkeying around with and reformatting in a prettier style could conflict with somebody who had a branch going. So it was kind of a scenario where it's like, all right, I'm not calling this a lock, but basically everybody stop doing something for a minute. I'm going to just format the whole thing all at once so that we can reduce the conflict, because that's the strategy that worked well for us.
Same kind of thing with the remote repositories. I mean, if you're trying to separate a subcontractor who's working on part of the code, then they have to get your permission, right? To check
Mm-hmm.
things in.
Yeah, you could totally control that at a permission level if you needed it, like a temporary, hey, we're putting out a new big version and it's going to cause a bunch of stuff, so we're going to like lock out your access. I suppose that could work. Yeah.
Can you tell Git to ignore format indentation, for instance, or something like that, as a difference?
Um,
Or is that, is
I
that
don't. I think it's like.
is that your tool?
Yeah, because it's like Git just knows about bytes and characters, so it's not cognizant of a language, style issues. It's just looking at, like, do the characters on this line differ? And because of that, there's not a lot it can do to say, I'm going to ignore the fact that you reformatted everything to be 2 spaces instead of 4 spaces for our code, or whatever. Any other questions? Cool. Well, thank you very much.